Good morning, friends. Today, let's continue with class 9 mathematics, chapter 2 polynomials, exercise 2.2. Now, in the previous videos of polynomials, introduction part 1 and part 2, you will find that in the class 10 section, which is benefiting even class 9. You can kindly go through those two intro videos. That will really help you in identifying what are polynomials and how to solve polynomials. Now moving on to this question, that is exercise 2.2. I've exactly discussed up to zeros, different kinds of polynomials, how to identify the degrees. So kindly go through the videos again. Now the question is, find the value of the polynomial 5x minus 4x squared plus 3 at x equal to minus 1. So let us name the polynomial, that is, let our polynomial be, no need to arrange because we just have to find out the value of the polynomial here. So now that is at x equal to minus 1. That means at x equal to minus 1, that means the values of x should all be changed to minus 1. That is p of minus 1. This was a polynomial in the variable x. Now I will find out the value of the polynomial at the value minus 1. So that will be 5 into minus 1, 4 into minus 1 square plus 3. That will be minus 5 plus, minus 4 into plus 1, because minus 1 square, even numbers, square of every even, whenever the power is even number, the values will all be positive. 3, so that is minus 5 minus 4 plus 3 minus 9 plus 3, so the value is minus 6. Moving on, similar question number 2. Find out the value of the polynomial at 0, at 1 and at 2 for each of the following polynomials. Our polynomial, I'll be doing question number 4. Our polynomial is given p of x equal to x minus 1 into x plus 1. So let's find out now one by one. P of 0, that is x will be replaced by 0 in this given polynomial. It's simple. So 0 minus 1, 0 plus 1. That means wherever there is 0, you will just you will just replace it by 0. Simple as that. So that's minus 1 plus 1. So 1, this is multiplication. So 1 ones are 1, plus minus minus. Next, at p of 1, that is again, you will have to find out the value of the polynomial at x equal to 1. That means x will be replaced by 1, only the value of the variables. 1 minus 1 into 1 plus 1, simple as that. So 1 minus 1, 0, into 1 plus 1, 2. So answer is again 0. Next value, p of 2. So that will be, instead of x we will use 2, instead of x we will use 2. So that's 2 minus 1, 1, into 2 plus 1, 3. So the value will be 3. So that's how simple it is, just to find out the values of the polynomial at the given values when the polynomial is given in terms of certain variables. Moving on to question number 3. Verify whether the following are zeros of the polynomial indicated against them. This is the polynomial that is given to us, that is 3x plus 1. So we have to find out at x equal to minus 1 by 3. Verify whether the following are zeros or not. We discussed about zeros, that is, zeros are those values of the variable which when substituted in the polynomial should turn the polynomial to 0. So let's check. So let's find out the value of the polynomial at x equal to minus 1 by 3. That means x will be replaced by minus 1 by 3 in the given polynomial. So here we have x. So 3 into minus 1 by 3 plus 1. I'll elaborate. 3 into minus 1 by 3 plus 1. Let's use this bracket so that we don't confuse it with this term. So 3, 3. So minus 1 plus 1, 0. So what do we have here? We get 0. That means like at x equal to minus 1 by 3, the value of our polynomial turns out to be 0. So therefore x equal to minus 1 by 3 is a 0 of our given polynomial. Simple as that. That means we should have zeros. Again, moving on to one more question, let's say like number 6. Find out the value of the polynomial Lx plus m at x equal to minus m by L. So at x equal to minus m by L, let's find out the value of the polynomial p of x, Lx plus m. Don't be confused with the letters, okay my dear students, just the value of the variable will change, that is at x, that is minus m by L. That means khali x lawa value to replace koribo by the given value, that is L into only the x plus m. So L, that is minus m plus m. So here also what do we have? 0. So therefore x equal to minus m by L is a 0 of the given polynomial. Simple as that. Now moving on to question number, that means if you don't get 0, I'll do one more question, like question number 2. Our p of x is given 5x minus pi. You have to check whether x equal to 4 by 5 is a 0 or not. So x equal to 4 by 5. Let's find out p of 4 by 5. So 5 into 4 by 5 minus pi. So 5 cancel. We have 4 minus pi. Now 4 minus pi will never be equal to 0. So therefore x equal to 4 by 5 is not a 0 of our given polynomial. Moving on to the last question, that is question number 4. Find the 0 of the polynomial in each of the following. Like question number 3, the polynomial is given 2x plus 3. In the previous question, the values of x were given to us. We were just supposed to test or check whether those values of x were actually zeros of the given polynomial or not. Here we have to find the zeros. So to find the zeros, that means to find the zeros means what value, particular value of x, which when you substitute here in this given polynomial will convert this whole polynomial to 0. We have to find out that value, particular value of, unique value of x. This is a linear polynomial, so we will have only one 0. So what we will do is, for zeros, what should happen? Our polynomial should become 0. Simple as that. So that means what is our polynomial? 2x plus 3. This should become 0. This is the best way to do it, instead of just by hit and trial method. So let's simplify this. Plus 3 will go to the other side, minus 3. So x, again dividing both sides by 2. So x or cross multiplying, minus 3 by 2. So x equal to minus 3 by 2. Therefore x equal to minus 3 by 2 is a 0 of p of x. Now what does this mean? It means that when the value of x is minus 3 by 2 in the given polynomial, our polynomial will completely change to 0. Let us verify this for our sake, not needed in the exams, but let us try to verify for our sake. So that will be p of x as 2x plus 3. Let's try to put the value of x, which we have calculated, minus 3 by 2. So 2 cancels. We have minus 3 plus 3. That is what we have here, 0. Exactly. So continuing on with one more question, that is question number 6. That will be p of x is equal to ax, a not equal to 0. So again with the same concept, for any zeros, what should happen? Our polynomial should turn to 0. Now what is our polynomial here? Ax equal to 0. So x will be equal to 0 by a, dividing both sides by a. So x equal to 0. So x equal to 0 is a 0 of our given polynomial. So here our value of x is 0. Thank you so much. I hope you have liked this video. Do tune in for more videos.